Namaskar and welcome to this exciting new episode of Sattology, Debunking Mythology. Today we are talking about the science and the how the Sanatan Dharma is all science. So before we continue, as usual, Sat means truth. Sattology means science of truth or study of truth. Sathology is not a replacement for history or itihas. It's an adjective. Just like they say mythological, mythology, that is an adjective. So mythology, it is a true antonym of mythology. Mythology means science of fake, imaginary, or a lie. So in these episodes, through discussions, we bring out some important aspects. So Sanatan Dharma is such a well-documented history of the world or the science in the world that one person cannot do justice. All of us are like small bubbles in that ocean. So with that, I would like to invite one of my best friends, and Rishi, Muni, and Tapaswi. You can call him, like he has been publishing papers when I was like in my infancy, and for so many years he has been doing it. So without delay, let us welcome Sri Nilesh Nilkant Oak. Namaskar.
Namaskar, Aditya ji. And yes, I have published papers, but I got so disillusioned with the peer review process so fast when I was doing my master's, right early. In fact, my master's thesis by all the external examiners, including one external professor from the same department, chemical engineering, was said, it was a master's thesis. They said this is more than a PhD. Okay, so but when I got into the peer review process, I mean, for chemical engineering, that was not an issue. But even in chemical engineering, to publish in a peer-reviewed paper, a peer-reviewed journals, I found it to be very inefficient process. Now, peer review has its place, but what I do today, and especially in this space, the Indic knowledge space or Indian civilizational, the Sattology or Sat of the Indian civilization, I would say I don't have any peers, or I have very few peers. So which journal I can publish? The peer review needs peers. So when the other folks in Indian civilization raise their standards, then I may consider publishing in their peer-reviewed journals. But for now, it's like the last few sessions we are discussing these papers, like Dr. Ashok Bhatnagar or Professor R.N. Iyengar. And I would say with no emotion attached whatsoever, when I looked at it, because me being as a Mahabharata researcher, when I looked at their Mahabharata researcher, I would say it would not qualify the scientific level, scientific acumen, logical reasoning of beyond elementary school, beyond fifth standard. And this is not a comment on them. Huh? This is a comment on their work, because they might have done some great work in some other area. That is not to discount that. In fact, like I mentioned, Professor Iyengar's translation of what is that, Parashar Tantra, which is a great service to our civilization. Now myself or Rupa Bhattiji don't agree with his interpretation. And my hope is that not just with Professor R.N. Iyengar, but many of our Indic researchers, even our pro-Indic researchers, that they come out of the hiding, come out in the front and platform like Sattology, and we can have a very healthy discussion, debate, and expand the envelope of the knowledge of Indian civilization and go towards the truth.
You made great point, and because throughout the history in Sanatana Dharma is all about conversations, discussions, and dialogues. Munaya sadhu prishtoham bhavidi mulok mangalam. People ask questions, people reply questions, and that is a different type of ananda, enjoyment.
Yes.
And so we should not go away or deprive other people of the ananda also. While at the same time, we can also have the ananda,
right,
while they're discussing these things.
Correct.
So yes, and also I invite you to write on sathology.org. So you can create your account, you can write over there. And others are also invited to write over there, because the ultimate goal is to move people away from the platforms which actually work against Hinduism, like Wikipedia, Quora, and all these people, where Hindus are not allowed to edit. Like if
Correct.
you put Ramayana history properly, they don't allow you to edit, and
Right.
it is a big problem,
Yeah.
because a small kid in India is just going to Wikipedia by default, because he
Yeah.
gets all the information over there. So
Correct.
probably pick up the Western information there, because it's designed for Western audience or Islamic audience. But for India, you don't have to rely on that, because they don't have
Correct.
any information.
Yeah.
Chinese don't allow it in their own country.
There you go.
Japan allows them with a lot of caution. There are a lot of laws.
Hmm.
Russia also doesn't allow Wikipedia completely freely. Only in India it is available. So all these people use Wikipedia to destroy Sanatan Dharma or a Hindu culture. And so please use carefully. Just like
Yes.
they write on a cigarette label, smoking is injurious to health. Similarly, Wikipedia is injurious to Hindu health,
Correct.
at least on the philosophy side.
Right. And therefore, I would just add at least two things. For common knowledge, like to know the capital of Canada or United States, it's perfectly okay to use it.
Correct.
And definitely do not support by donating to Wikipedia
Right.
or any of such things. Definitely do not support. And that is not enough. You have to, I mean, each one of us who is watching this and eventually will watch through YouTube and other mediums, they must educate their family members, their neighbors, their relatives, their friends, their colleagues on this. You cannot leave it to few individuals to educate this. Okay, so that's also very important about Wikipedia. I know now quite a few Wikipedia editors, and they were editing Wikipedia pages for a long time. But when they got into, and these are people from all over the world, they are not just of Indian origin, but when they got into editing the information about Indian civilization from a very extremely, what you can say, illogical, unscientific, dogmatic information that is been created by Western Indologists of last 200 years, when they tried to change it, backed by even evidence, they were removed as editors from Wikipedia. It is that vicious. Even they are not interested in the true evidence.
Yeah, like I try to edit the page of Arabic Hindu numerals, and
Hmm.
I try to put R.A. Bhatia as a Brahma Gupta as a original founders, and they did not allow me. And this is my example, Sattology's example.
So on that subject of Aryabhatta and Brahmagupta, that is a good segue for our subject today. And we'll talk at least three aspects of um, the mysteries, three mysteries of Indian astronomy. Mysteries may be one word, but three very unique aspects. And especially when you understand the antiquity and then you try to look at even the modern discussion, even the discussion today, like in the schools, like my daughter and the school, like big deal about the pi, like a few years ago, middle school or elementary, I forgot now, but she would come home and says, "Daddy, do you know if we can calculate the accurate value of the pi, and when was it first calculated?" And I just said a number, and she said, "What?" I said, "Yeah, that, I mean, I don't know when it was calculated, but the very precise value of pi was definitely known to us for more than 17,000 years ago." And she said, "What? Oh, you mean 1700?" I said, "No, 17,000. Do you mean 1700 BC?" I said, "No, I'm talking 17,000 BC or 14,000 BC." And that's the kind of very faulty information is there in the social media or Wikipedia and what. So if you want to add something, you add it, and then I'll get into the presentation.
Everybody loves mysteries, and you chose such a perfect word over there. We are all trying to undiscover the mystery and or rediscover the mystery. But here's the biggest mystery. So let's get started then.
Okay, right. And so what I am going to do here, again through the examples, to give a glimpse into the sophistication, precision, and accuracy of our Indian science. Indian science, you can divide it into many different areas, like textile is one, navigation is another, like boat building in terms of science, but also technology. Ayurveda, which is also science and technology, agriculture, domestication of animals, metallurgy, and just goes on and on. The one specific area, and again, somewhat biased from my point of view, because It just so happened. Of course, I like astronomy, but so does I like Ayurveda. And honestly, Aditya ji, I love music in general, like the Western classical, the Indian classical, within the Indian classical, the Karnataki, the Hindustani, and also the Drupad, much older. I love all of it, but I'm not an expert. For example, like I'm listening to it all my life. Maybe first few years I didn't necessarily like it. Then last 25 plus years, I tried methodically to study it so that at least I can enjoy more. I do enjoy it. I mean, a lot, but still I am, maybe my brain is not wired for it. Still the sare gama pa, I don't understand it. The after like 10 years, I mean, I started this deep study in 1997 or so of the Indian classical music, especially Hindustani classical, like the khayal singing. My point is, I'm very much deep into it in terms of as a consumer of it, but I'm not an expert to talk about it. So sometimes what happens is I tend to pick subjects which kind of where I have done a lot of work. And so here, what I'm doing in this today's session is just to bring a glimpse of it, just to give a glimpse. And the idea again is always the same, that hopefully we, through our conversation, inspire few folks, those people, those students in the universities, when their exams are over, they can consider doing this or on the weekend. It's extremely fascinating, guys. I mean, I watch serials like the on the online platform, but honestly I'll tell you, I don't need extra entertainment. This is so fascinating, and the idea is to give a glimpse that hopefully you get to the original text that I'm going to mention from Indian astronomy. So one of the big subject, again, I don't want to call this Purva Paksha, but something that is happening is just few episodes ago, we discussed Dr. Konrad Elst, and he writing in Pragyata, where he claimed Mahabharata timing only during the second millennium BC and nowhere else. And now we are looking at a series of claims from the second millennium, like Ashok Bhatnagarji, and we show how disastrous that whole claim is. Or last 2 or 3 episodes we spent on so-called claim of Professor Aryan Iyengar for 1478. I have also shown what a disaster that is. And frankly, the disaster is not over. We will do a couple more episodes on it. Then there is Dr. Dieter Koch, and we can take 1 or 2 episodes and we do that as well. And I don't know if anyone else is left in that whole area. There is Professor Mohan Gupta around 1952 or somewhere there. We might do that. In fact, the book I need, where Professor Mohan Gupta has written his claim, is in the library, like the Emory University library here. And right now, because of COVID, I don't have access to it. So I cannot check out that book. And that's why I'm kind of holding on to it. But today, even what Konrad Elst, like besides that Mahabharata, he also makes another claim. And this is not a new claim. He's making this claim for a long time. My good friend, by the way, since I met him, let's say possibly 4 or 5 years ago, and I'm aware of his work for a long time. Good writer, I mean, writing style. But certain areas, like when it comes to Mahabharata, I mean, absolutely. I mean, I have to put a lot of effort, Aditya ji, not to laugh when I hear this second millennium claims. Okay, I mean, he makes a generic statement, but many other folks who have a specific claim, it's laughable. In fact, it tells you that they have not bothered to read Mahabharata, and they are really depending on the secondary works of other folks. Similarly, but get back to today's subject, Konrad Elst also makes a very persistent about making this claim that the certain aspects of Indian astronomy came from Greeks. Okay. And then, if you push him, then he will say, well, I'm not saying everything, I'm saying some aspects. But if you ask, he will not clarify what those aspects are. Then the discussion may turn into astrology. So I'm not going to discuss astrology today, but just before I get into astronomy, let me make a comment on astrology. That is also an extremely disastrous, without any basis claim for the astrology coming from Greece to India. Here is how. The current a dating of Greek, and I don't know what evidence they use, but I have studied Greek science for a long time. Okay, so Thales, Anaximander, okay, Xenophanes, and then of course later on the Socrates and Aristotle and Plato, and I mean I have done all of this. But the timing that is assigned does not go back beyond 800 BC. If you stretch, it might go to 1000 BC, but even beyond 500 BC is also a stretch, really. The second thing is number of these characters that we are referring to, their text them are not available. We are making judgment about what Socrates said based on what other Greek writers wrote about Socrates. We don't have an original text of a Socrates, at least not to my knowledge, and I would love to be wrong. So when they talk of, when someone like Konrad says, when Jayant Narikar, okay, that Dr. Jayant Narikar, he also has claimed that it came from Greek, the astrology. I mean, where do these guys get this idea, and why would they not read the original text? Even just limiting to astrology, what we have, and there are many astrology texts, but just take one, which is the most popular, you would say, is the Parashara Hora Shastra. Again, I'm not an astrologer. I'm just talking from the dating perspective. The Parashara Hora Shastra, we don't know exactly when it was composed, when it was written. And naturally, the astronomy text as well as the astrology text, they do get updates. They need to be updated in order to accurately find out the positions, because over time, the astronomy parameters change. If we look at the latest update to Parashara Hora Shastra, and I don't have it here handy with me, so we may do that another time if somebody raises the question. Based on the internal reference for possibly the update to Parashar Hora Shastra, the astrology text, takes us back to 1200 BCE. That is before the historically documented or even speculated timing of the Greeks. So on what basis these guys claim that the astrology came from Greek to India? Number one. Number two, I don't understand linguistics. I do not claim to know linguistics. But then they get into centum and centum debate, the like shata, like, shata in the sense of a century, 100, that is the word. But then there is a ka. Instead of a sh, it's a ka. And the word kentum, like the kendra. So they say the words that are used as a kendra in Indian language, they come from the Greek, and they might have. Now, here is the fun part. So they say, oh, that word kendra that you see in coming from in Indian text is coming from Greek. Now, that might have, but that is not a guarantee. Therefore, the Greek astrology came here, because the word kendra does come into Surya Siddhanta. But the meaning in which the word kendra comes in Surya Siddhanta has absolutely nothing to do the way the kendra word is used in Greek language. Okay, so that's just quickly on the astrology part. And every time Dr. Konrad Els raises this bogey of astrology coming or astronomy coming from the Greek, I said, what is your evidence? And then he disappears. Every single time, no exceptions to this day. Okay, if somebody can explain that behavior to me, let me know. So with that, who borrowed from whom? So let's start with this, because when we have this problem, when we have this dilemma, people's attention is better. Now, Konrad Elst is essentially not claiming to be the original researchers of this area. He's going he's making his statement based on what others have said. And do you know who those others are? For example, Professor David Pingree, now late David Pingree of Brown University. And his students continue that dogmatic claim. So if you read Professor Pingree's thesis or some of his papers, it appears as if like he was given the agenda, the agenda-driven research. Hey man, just go ahead and prove that the Indian astronomy came from Greek astronomy. And then so this poor guy is just putting his all efforts to somehow prove it. I'm calling him poor guy. Do you know what it is? His title was something very impressive: the professor of exact sciences at Brown University. Okay, and his students are continue to follow this. So let us, against that claim that it came from Greek to India, let us look at first thing the differences between the two, how that could not have came, if at all. And I don't want to get into the discussion of if Greek got it from India, because I don't know what the Greek texts are in astronomy. So how can I even say that it came from India? But I'll show you the later Greek text or after Greek, like Ptolemy. Now they also see, oh, Ptolemy is also Greek, and this guy is also Greek. But the reality and now history is showing that most of the, even the so-called astronomy of Greek was essentially borrowed and stolen from the Egyptians. Okay, so that is becoming very clear. Euclid is a myth. Those people who want to read about it, they may consider, actually they should read a book, Euclid and Jesus by Professor C.K. Raju. He has made an open award saying, bring me the proof, objectively testable primary proof, not secondary sources, for the existence of Euclid, and that person will get certain money. And this he did for many years ago. Nobody has come forward. So that's another totally fake narrative that has been created. So against this background, let us look at who borrowed from whom, if at all there was a borrowing. So ancient Indian astronomy and faulty interpretations of Western Indologists. Here I'm specifically referring to David Pingree, his students like Kim Flocker, who's around, okay, by the way, a professor of mathematics or astronomy or whatnot. Another one, if you look at the Greek text, Herodotus and some others, and it is some their descriptions of the world, they had a description of a flat earth. Okay, and I'm not saying that they did not have the descriptions of the spherical earth either. There were some people who indeed visualized the spherical earth. Even they went to the extent of estimating the circumference of the earth and didn't do that well job. But whatever they did was impressive considering rest of the development in the Western Europe or Greek and Roman world. Okay, especially knowing the rudimentary mathematics that they had. I mean, Greeks were scared of zero. Let's put it this way. They were scared of using zero. Now, if you don't use zero and if you don't understand the decimal system, I am at loss how you can perform sophisticated calculations. But one quick point, and I'm going to take you there as to how old is this text. But without telling you this, I am going to show you something that you can ignore that 580 CE. I'm not going to go there. Only by stating that the latest update to Surya Siddhanta, we can show that it did occur around 580 CE. And as I said, the astronomy texts do need periodic update because astronomy parameters do change that are used for the calculation of the positions of the sun and the moon and the planets and whatnot, okay? Specific locations, because Earth is going through all kinds of changes, the precession of the Earth's axis, the obliquity change, and many other cycles. This is from Surya Siddhanta. And those people who wonder if Europe wasn't so sure about if the Earth is flat or circular, they were thinking, many of them were thinking it's a flat. But is there somebody out there in the world who knew that it was spherical? This is a statement from Surya Siddhanta, and we will see how old is Surya Siddhanta in a minute. So what Surya Siddhanta is saying, Sarvatraiva mahi gole swasthana mupari sthitam manyate khe yato golas tasya kwa ardha kwa vapyadha. Everywhere on the surface of the terrestrial globe, people suppose their own place to be higher. Like everyone thinks, whoever they are, whatever the color they belong to, whatever the status they belong to, the gender they belong to, that's the best, right? I mean, that's just people's thinking, not correct, but so they think higher. Yet this globe is in space, Surya Siddhanta says, where there is no above and nor below. Okay, so the Earth is in the space, it is spherical in nature to the extent that there is no particular spot which is superior to any other was known to Surya Siddhanta writers. Quickly get into the subject I want to discuss, the Indian versus Greek planetary models. There are like 10 different aspects that we can discuss, but I'm going to discuss specifically two. Now, something very interesting, guys, here. What you're seeing on the left side so let me show the arrow in case, someone is confused about which is left, depending on what you are seeing. Here, this area is in a simplistic fashion. That is the Greek model. So Earth is here. Notice Earth, the Ptolemy, we say, okay, it was Earth at the center. Yes and no. Okay, so directionally, yes. But if you get into more nitty-gritty details, actually not. The Earth is not at the center, but rather the off center. And the whole thing, the other planets and everything are moving in that model as if around a imaginary center. At that center, there is nothing. Okay. If those of you who understand the conics and understand astronomy, they will know that in a way it is a partly correct statement. Okay, there is no true exact center, but let's go on. And then there are some other centers, okay, meant for some different purposes. So some of the things are rotating around some other centers, which is neither that center nor Earth, but some other center. Okay. Then what is happening? These are those epicycles. So individual planet is not actually going around the Earth either in that in that geocentric model, but it is going around its own center. This is what is called epicycle, and that particular point itself is going around the Earth or around that imaginary center. Something else. For Greek calculations, they used the radius of 60. Okay, where did they get 60? Totally another huge subject. For example, the 60 is well known in the Indian system, it is well known in the Babylonian system, but I will not go there today. Okay, but they picked up. Now, this is a good example of number of you students. I'm not encouraging you, you shouldn't be doing it to maintain your integrity, copying from somebody else, but the copying does happen. And when that happens, and suppose the person who is copying from somebody else, but this person who is copying has no idea what he is copying, just trying to write as fast as he or she can to cover it, what's going to happen? Whatever the person copies, person is hoping that it makes sense to the professor, but to him or her, it may not make any sense. What this model did is, as if like it's a copying, it made the astronomical calculations extremely cumbersome, a nightmare. Now, to add to that, their inability to make efficient calculations because of their fear of zero, or even when they afterwards understood a decimal system, now their understanding of decimal system is very late, extremely late. Okay, so even when they became aware of zero, they did not adopt it. It took like centuries before finally they could do it. The name zero was given Sefer. It was to mean mysterious. So by the way, that is another mystery. The Romans, Greek, Western Europe thought of zero as a mystery. Go figure. Now, in a way, it is. Now we take it for granted. Okay, but if you see Indian system, Indian civilization, they are using not only zero, but even more important than zero is the decimal system, or even more important than the decimal system is the place value. The decimal system has a sense of a place value. So 0, 10, 100, and so on. But the place value of a number, not just for zero, that is the biggest invention, you can say, and biggest contribution of Indian civilization. Now, how old is that? Oh, you see that in Mahabharata, that's 7,500 years ago. You see that in Ramayana, more than 14,000 years ago. You see that in Rigveda, more than 22,000 years ago. Now, against this cumbersome Greek model, let us look at the Indian model. This is from Surya Siddhanta, and also you will find the same in Aryabhatiya. What is interesting? Look how simple it is, and please pay attention, because on the next slide, I'm going to show you, if you start from the first principle, and if you get your first principle right, then everything falls in place. Everything falls in place, just like my dating of Mahabharata or Ramayana. So here, something very curious, okay? While the Greeks use an arbitrary and cumbersome value of 60 units, it turned out to be cumbersome for calculation purposes. The Indians chose a very curious number. Okay, so let's call this for now the mystery of 3438, and we will solve it today, okay? Which is ingenious and remarkable. You just take it on a leap of Shraddha, on leap of faith for now. But what this did, is this. So Earth at the center. So for calculation purposes, Indians, Surya Siddhanta or even Aryabhatiya also use the model as if Earth is at the center. But remember, it is a model to find the position of planet, sun, moon in the sky. Why? Because this was not done just for the heck of it. This was done for very useful purpose. What was the useful purpose? Useful purpose of agriculture, to predict the forecast. I mean, predict and forecast the weather, predict and forecast the rain, the beginning of a rain, the heavy rain, the end of the rainy season, the cloudy season, and so on. It was also used for navigation. And even more important than agriculture, when it came to navigation, this was a question of life and death. You are in the middle of an ocean going on a boat where you cannot see anything else. Your only reference where you are and where you want to go and how far your destination is was the astronomy. Okay, so it needed to be very precise, and that's why this you see the geocentric calculation, because the outcome of this calculation is used on the Earth. That's why it was made as a model, as a geocentric model. Okay. Now, the radius that is used is 3438. And somebody will quickly jump and say, oh, but what is the unit? Guess what, guys? We don't need the unit. We are looking at the angular distance here. Okay. Something very fascinating. I'm just going to give you a glimpse of it. As I said, I can go on and on just on this slide for possibly a couple hours or half a day. Okay. Now, what you see, these other epicycles, something like epicycles. So Indian system has epicycles before even Greek could pronounce a word. Okay. The epicycles, but the Indians had even more sophisticated epicycles. Do you notice something? So just like this epicycle here, the Indian system also has epicycles. But what do you notice about it? That they, Adityaji, what do you notice when you look at these Indian epicycles here on the circle in comparison to the Greek epicycle?
Yeah. So there is
The
no,
one,
yeah,
yeah,
there is no additional movement of other objects.
there is no additional movement of other object. Well, there is some, which is to say on this epicycle, the point could be shown here, the
Yeah.
planet or whatever is here versus here. But one thing is, if you notice the change of dimensions, like this epicycle is smaller, this epicycle is bigger.
Bigger.
This epicycle is of a different size, and so on. And they could change as you go from one point to another. They were known, or they can be, now we can name it, they just explain it, pulsating epicycles. And what essentially they are doing, those people who love astronomy, those people who are in mathematics, listening to it right now, and science, you love this. They are using the pulsating epicycle, the concept, the modeling of a pulsating epicycles to simulate the elliptical path of the planet around the Earth. And they did this for every planet, including, of course, sun and moon. And this is, I mean, what I'm showing you right now, this is beautifully brought it out by Dr. Anil Narayanan. And again, those people who love peer-reviewed papers, his 4+ papers are out there in peer-reviewed journals. So I would encourage you to read those. Dr. Anil Narayanan, he worked for ISRO, and now he works as a consultant in America. So what is the beauty of this 3438? Though again, those of you who are a math major in astronomy and in general, pull the formula. Remember, this was used to track the positions of the planets, positions of sun, moon, which are also considered planet in the Indian system. Not planet, they are called graha, okay, which is different than graha is something that is grasped. And planet from the Greek meant wanderers, right? Because everything else you could see as steady, but not these planets. They were going back and forth and changing. They were called wanderers, and that's what the planet means. But to know even the position of the sun and the moon, which you can say very predictable, and especially when you are navigating through the oceans, you need to know how far you have traveled. And guess what? During the day, of course, they had a sun, the sun's angle to look at, and so on. At night, the specific stars, the pole stars, and many other prominent stars. And they knew exactly what time, which stars will show up. And based on that, they could decide where they are. But something very interesting, if you're looking at the sky at night, let's say, and noting down the star, your natural resolution of your naked eye like a good view eyesight, naked eye, is 1 arc minute. And if you take the entire Earth, you can say the whole circle, the celestial circle, and you think of the celestial circle as 24 hours because they make a whole turn. All the stars, sun, etc. will make complete turn in 24 hours. Then each hour is, because total is 360 degrees. So, so stay with me. So 24 hours. So we are taking 360 degrees turn into 24 hours. If you do the math, that comes to 15 degrees per hour. Now we have to translate that into arc minute, which is the natural resolution of your naked eye, because you can just look at the sky, note down what is the change from your previous location, maybe an hour ago, since you were doing the boat riding, and now see what difference it is, make a correction for the change in time, and you know how far you have traveled. So 15 degrees in 1 hour, total of 24 hours. So if you stay with me, 24 times 15 times 60 minutes, because we need a natural resolution of 60 arc minute. 24 times 15 times 60 gives you 21,600. I would encourage all of you to go to the Wikipedia that I said, otherwise don't go there, or just type in Google and find out what is the Earth's diameter, especially at equator, because that's the reference point. And I'll show you how beautiful was the Indian astronomy. The center for Indian astronomy was Lanka, where the observations were made. And what is the location of Lanka? 0 prime meridian and 0 latitude. So right on the equator and on the prime meridian, but not the prime meridian of today, which was taken by British from India in around 1850, 1858, from Ujjain to Greenwich. That's not the one I'm saying, the one that went through Ujjain. So prime meridian going through Ujjain and Kurukshetra and cutting at the equator, that is the location of Lanka, and that is from where people made astronomy observations in the Indian context. Why? From at the equator, if you look at the Earth's circumference, and you can go and check in Wikipedia or Google, you'll get the number. It was a 21,600 nautical miles. Guys, I'm telling you multiple mysteries. 21,600 nautical miles. Okay. Now, lo and behold, how many things are out there that we miss? This was brought to my attention by another individual who comes on Adityaji's program, Mrs. Rupa Bhatti. She brought it to my attention, and why Columbus got the wrong circumference, because he was not measuring at the equator, but in a crude fashion, or not Columbus, but whoever measured for him before, it was measured in Europe, but they did not understand. So when you blindly copy, obviously you're going to make errors. So now what the hell has to do with the 21,600? Aha. Now, remember, what is the formula for circumference? So this is my radius. So radius circumference is equal to 2 pi r. 2 pi, you know the value of a pi, okay? Or you can make a perfect approximation, use your calculators. And r, the radius of 3438. It will give you the number 21,600, or approximate number close to it. You see the beauty? So the beauty is, when the Indian astronomy calculations were used, all you have to do is look at the position, make a correction for the time, plug in the number into this calculation. Wherever you see, that is already accurate for this formula, because the whole circumference was divided into 21,600 arc minutes. And when you look at the position of the star, or change in the position of a star, the natural change you're noticing is in arc minute, because that is the natural limit of resolution of your naked eye. That is one mystery, but actually a series of 4 or 5 mysteries that I gave you here. Let's look at the next model difference between Greek and Indian model. If anyone is holding this dogma of Greek giving astronomy to India, okay, and if you're watching this, this should be, if you really understood this, this should be the end of dogma for you today. So let's look at the astral bodies, okay? Remember, we saw the model on the previous page. Again, this is a wonderful work of Dr. Ali Narayan. So you have these astral bodies or graha listed: Sun, Moon, Mercury, all the way to Saturn. That is something visible to the naked eye. And look at the Greek model. Okay. Now, when I say Greek model, it is really Ptolemy and after Ptolemy. Many modifications that happen with the help of Arab astronomy, which in turn was benefited because of the Indian astronomy. And Arab did make their some additions, okay, because of their own observations. Okay, there were some good mathematicians in the Arab world, and that through Cordoba, through Spain, it finally came to Europe. So the modifications continued, but when we say Greek model, we are looking at really the end of Greek period. Okay, like 0 CE, 0 BCE. That time is where the time of Ptolemy. Okay, so what is that model? A single epicycle model, just like what I showed you. Okay, for each planet. Then what happens? There is a CCM, central crank mechanism. We may not have a time to go into that. Then there is a variable apogee when you see the word VA, that is only used in case of a moon. And then there is a equant. Okay, we're not going to the details, but let's see how that model works. So for the sun, it's a single epicycle model. And let me tell you, the Indian model for the position of the sun is multiple times more accurate than the Greek model. So that's a mystery number one, or surprise number one, especially those people who are stuck into Greek astronomy as the basis. But here is the sensational news. I'm saying the Indian model for the sun is much more, multiple times accurate, and there are papers that you can read, than the Greek model for the position of the sun. But one more difference. The so-called Greek model for the position of the sun, we are talking about, let's say, simplify 500 BCE. The accurate Indian model for it is called equation of the sun for the predicting the position of the sun is most accurate when you go back to the Mahabharata time. And as soon as we talk of Mahabharata time, because we are doing all this debate, when did Mahabharata with 100 different claims, let me say it goes back to 5561 BC, specifically 5300 BC, 5500 BC. So the Indian model for the equation of the sun, the predicting the position of the sun, was perfected or was recalibrated, readjusted in 5500 BCE. So the model possibly existed before, it was readjusted, recalibrated in 5500 BC. But let's go on. Now look at the simplicity. Just if you look at the Greek model column and the Indian model column. So Greek model SE for moon, they were really in the puzzle. In fact, that is true. I mean, not to just blame Greek. The predicting the moon is the most complicated thing. I mean, Newton was scratching his head for 15 years, 1-5. His theory was there, otherwise ready. So what is the model versus the Indian model for moon? Sun is what? SE versus SPE. SPE refers to single pulsating epicycle. Remember the cycle I showed you? That circle, and yes, there are epicycles, but they change their size, and they change their size to mimic or to model the elliptical orbit of the graha around the Earth. When you go to the moon and then the future planets, look at the Greek model. Like moon is like a standalone model. Then the Mercury is kind of a standalone model. And then the Venus, Mars, Jupiter, they use the single epicycle plus the equant. And actually, it's a very, very crude model. The Greek model, Ptolemy, and afterwards is extremely crude. In fact, that was the very reason Copernicus wanted to do something different. Because every time their prediction would come out wrong, they would add one more epicycle to the model to fix the problem. To the extent, do you know how many epicycles were there? So they started with the single epicycle for single planet, but epicycle over epicycle over epicycle, such a thing. And in model, sometimes you do that. So I'm not blaming them because they couldn't think of anything else. But by the time Copernicus came on the scene, which is what, 15th century, 16th century, there were in the you can say the Greek model or the Western European, what you call geocentric model, there were 70 plus epicycles. So there are only what, 5 plus 6, 7 bodies, But to explain the motions of those 7 bodies, in addition to the other mechanisms and all that, equants and whatnot, there were 70 epicycles or epicycles. Whereas now against that, look at, and what, by the way, Copernicus, what he did when he turned it from a geocentric to a heliocentric, the sun at the center, something was right. Why? How do we know that? He did not solve all the problem, but the number of epicycles from 70, it suddenly came down. I mean, not even in Copernicus' time, because Copernicus published this only when he was dying. But based on a Copernicus model, when people tried to improve it, these epicycles came down from 70 down to 34. They did not vanish until Kepler came on the scene, but that's a different story. Against this, look at the Indian model, and this Indian model is from Surya Siddhanta, and I'm going to show you how old is that Surya Siddhanta. You just have a single pulsating epicycle that I showed you on the previous page, and as you go away from the sun to moon and other planets, what you need is that correction of a SC, which is sun correction, you call it. You apply it to everywhere. And once you go into the planets, which is Mercury through Saturn, you have something called double pulsating epicycle that is given in the Surya Siddhanta. We will not go there. Now, the important question, this knowledge, which was much more accurate than the Greek astronomy, how old is it? The Greek astronomy, even just by a speculative standards, does not go beyond 500 BCE or 800 BCE, okay, by their own admission. And if they want to claim something, then they have to bring the evidence, and there is none, at least not that I am aware of. Okay, so but I would be very happy to know that evidence. I want everyone to understand, I don't have anything against Greek astronomy. Okay, in fact, when I read about Xenophanes, I mean, his Xenophanes poetry almost resembles like the Nasadiya Sukta of Rigveda. So I'm very fascinated by it. Or someone like Thales. Thales is someone who, at least in a Greek tradition, started the concept of critiquing or criticizing existing knowledge. It was just not there before. I mean, person could be punished, with poison and with very severe punishment. Now, against that, again, if you see in the Indian system, the whole knowledge is through dialogues. Different interpretations are allowed. And what you have to do is you have to provide a proof for your interpretation. So you just cannot speculate and stop there. Like Aditya talks about it all the time. He says philosophical versus speculation. So philosophical, you can say, is a theory, and scientific. Speculation is you say something, but you don't bother to bring the proof. I'm going to give you a quick summary of the Indian antiquity for the ancient Indian astronomy. We start 21st century. If you remember, I said the latest update to Surya Siddhanta definitely happened around 580 CE. I stated at the beginning. That is based on the longitudes values for the nakshatras in the Surya Siddhanta that we have. So it tells us that a correction definitely to the longitudes of nakshatra was made about 1400 years ago. But that is not the only correction. There is a two-pole star. Surya Siddhanta talks of two-pole stars, and then there are, related to that, there are many other astronomical strict conditions, two additional conditions at least I know of, and me and Rupa Bhattiji presented that paper at Oxford, the two-pole stars. And if you want to bring those three Surya Siddhanta references together from the same chapter, it doesn't have to be from same chapter, the 12th chapter, Bhugola Adhyay, that I showed you, where the earth is round and spherical and whatnot. These additional three references, the only time they come together and fit like a jigsaw puzzle is 12,000 BC. So that was possibly the update to Surya Siddhanta in 12,000 BC. But those are not the only two updates. If you look at the latitudes of nakshatra, the values of latitudes given for nakshatras in Surya Siddhanta, and you want to find out when they must have made that measurement, you can mathematically go back. Okay, it's a very exhaustive, very wonderful paper by, again, Anil Narayananji, that takes you to 7,500 BC, 7,800 BC, 8,000 BC. Equation of the sun that I mentioned, the most accurate equation of the sun until like the modern astronomy came on the scene last 300 years. It comes from Surya Siddhanta, takes you back to 5,300 BC, 5,500 BC. Obliquity of the Earth's axis possibly readjusted around 2900 BC. But Surya Siddhanta is also aware of obliquity of the earth equal to 24 going back to 12,000 BC. And if you look at the why the nakshatras sometime are 27 and sometime 28, that takes you to beyond 14,500 BC. These are, guys, only updates. And when do we make updates? When some system that we are using has some challenge now and needs to be recalibrated. So these are only updates going back to 16,000 years ago. But in order for some system to need a correction, need a repair, it must be functional before. And we can only estimate, and now we actually have evidence, I'll not go there. That takes us back to 26,000 years, 22,000 years, 40,000 years, 34,500 years, 38,000 years. This is again based on some of the measurements made in Surya Siddhanta. But quickly want to make one more point and I'll stop. The big deal about the pi. Number of you here, you would have heard this, like, right from your elementary, middle school, high school, the pi value, and what different formula you are using to get the most accurate pi value, Taylor series and different series and whatnot. And people make a big fuss about it. But that confusion, like even this obsession, I would say, to find the accurate value of pi comes from the confusion of the dogma of the mathematics, which came from a mathesis. And please go ahead and check. And this is another subject. This is not my expertise, like the English language. Go to online etymology dictionary and type any word and look for etymology of that English word. You'll find 50, 40, 50, 60, 70% of the time it's going to take you to the original root in so-called pi, P-I-E, Proto-Indo-European. By the way, that's another fakery. But anytime you see pi, if you know Sanskrit, you will immediately have a smile on your face because you will see the root of pi, that pi word, not this pi, not this P-I, P-I-E, Proto-Indo-European. And you say, yeah, I know the word that is in Sanskrit, which means this thing. So the word mathematics came from a mathesis, but the mathesis in term came from an intellect, knowledge, buddhi, from medha. And Aditya would immediately relate to that word medha nadi, like when you do yoga, when the kundalini is, activated, then it's the medha nadi opens up, the intellect, and the intellect flows, the buddhi flows, and stuff like that. It comes from that. Do check mathematics, etymology of mathematics. But today's point, the pi value, the obsession for the precision, accurate. My daughter comes home and, I used to and say, oh, daddy, can you tell me the pi value to 16 digits and 14 digits? And that's why I just picked it up. Something very interesting. This is from Aryabhatiya. Right now, people think the Aryabhatiya is again from 1500-year-old text. Yes, there are some updates that are made to Aryabhatiya, just like to Surya Siddhanta 1400, 1500 years ago. There is enough evidence in Aryabhatiya, or I should say there is evidence, maybe not enough, but there is evidence in Aryabhatiya to show, and that is something Mrs. Rupa Bhatti is working on it, I'm working on it, together independently, that Aryabhatiya is a very old text that goes back to thousands and thousands of years in antiquity, but because we have not published the paper, I will not go into that today. But this is the formula even from 1500 years ago, assuming that is what people, because nobody argues with that. Ganitapad, I will skip the Sanskrit portion, except one word. And here you can see the translation. This gives a circumference divided by diameter. It gives you a value of pi equal to 3.1416. The word that is Aryabhatiya using there, and the translation here is this. So, asanno, this word asanno here, okay, ayuta dvaya vishkambhasya asanno. That asanna refers to approximate. It means approximate. So Aryabhatiya is giving the value of a pi, and he's also saying, by the way, that's approximate, but enough for his purpose of astronomy calculation. Let me take you now to the final mystery and we'll stop. Surya Siddhanta, remember that ingenious number, the astronomy radius of 3438. In fact, I just said something that somebody will ask, what is the unit of that radius? And I said, well, there is no unit. It is a radius for measuring the arc distance. And can you use a radius without a unit? Well, actually, apparently you can. That is the beauty here. We don't have to think of the unit as a distance, because you have to say, just imagine the sky dome, at night, what you see above your sky, like above your head, is what I need to make an observation. And if somebody asks the question, what is the distance from where I am to where that star is? Of course, that's a different distance. But as far as I am concerned, watching from the earth at night, to me, as if those stars are essentially at the same distance on that sphere, on that celestial sphere. That's why we don't need a unit. At least that is the ingenuity of the Surya Siddhanta. But something else, Surya Siddhanta has a table of a signs. In fact, until Western Europe became aware of the Indian astronomy, they were having lots and lots of accidents on the ocean during their navigation, because they did not have the accurate values of signs. Okay, you can read a lot about this. I'll not go into the details. So Surya Siddhanta has the sign values. Aryabhati has the whole sign values in one shloka, one verse. Okay, he covers this whole table. Very, very fascinating, the mnemonic devices that were used. Anyways, the point I want to say is, if you see that number here, I should have highlighted it. So the sign number, it was a different way of representing, like a R sign. So that sign, R sign, that is given here is 3438 here. Okay, that is that magical number that I was referring to. Okay, and this is given in the Surya Siddhanta. What's the big deal? As I explained, 24 hours, each hour has 15 degrees. Why? Because the total should add up to 360 degrees. Time 60 minutes, because that's our natural resolution of our eye to distinguish two objects as not one with a naked eye against the sky, you can say, against the natural resolution, how far the eyes can see without any additional tools. And that comes to, if you multiply that, 21,600 arc minute. Notice what I said. If you go and look at the old measurements of the nautical mile, at the equator, they come to 21,600. Why? They are going on the ocean in a boat, and they need to know how far they went. Well, if there is a water everywhere, there is no reference point other than the stars. And you can notice the change of movement of the stars, plus because of the time, because of the earth rotation, but also because of their net movement over time and whatnot, or as seen from you, because you travel the distance on the ocean, and you can take that into account, the total time you spend plus the distance traveled by you, using the change in the stars angle, and you can find out how far you might have traveled. Okay, that's why the reference was used as a 21,600 nautical miles, referring to the natural resolution to note down the celestial object. How fascinating. Okay, the origin for the 21,600 nautical mile, you're going to only find in the Indian astronomy text. That is the mystery, that is the beauty. So quickly, I'm just doing this backward calculation. This is from Surya Siddhanta. So there in Aryabhatiya, he said it's approximate. Yes, it is approximate. So is this. So there the answer was 3.1416 or whatever that was. If you do the backward calculation here, because the assumption is it's 21,600 nautical miles or arc minute, the circumference, you do the backward calculation, plug in that R equal to 3438. That is that ingenious number, because it directly gives you 21,600. But now calculate backwards to see what is the value of pi that Surya Siddhanta is assuming. And the answer is, Surya Siddhanta is assuming 3.141361. Okay, again, it's an approximation. It's a practical, useful approximation. So Indian astronomers were not obsessed with getting a pi value accurate to like 15 digits and 18 digits and 200 digits. Actually, you can go into the Madhava series and you can find out how you can get it as precise as you want. But you want to know only to the precision that matters. Okay, there is no point, say, if distance from Atlanta to San Francisco. If I want to know, how do I want to know? I want to know the distance in miles. Okay, this many thousands of miles, that's good enough. I don't need to know the miles and then the feet and then the inches and subdivision. I don't need to know that. So even if it can be possible to calculate, I will not bother doing it. And that is the practicality, that is the pragmatism of ancient Indian astronomy. And you can see that in everything. You can see that in agriculture, you can see that in domestication, you can see that in navigation, you can see that Ayurveda everywhere. Okay, it was extremely practical and extremely pragmatic. I think that's my last slide. If you, I don't know if anyone watching, but if you're in India, there is a deal going on. You can get all my 3 books plus another wonderful book by Mitra Desai. I think she has been also on Aditya's show, Shitala. And so you can get that for package. Now, if you're in America, too bad, or outside India, no deal there. But if you're interested, these are my books, and we'll stop there.
So, in also your book is also available on Kapoth Publications. Also, I think shortly it will be available.
Which publication?
Kapoth.
Kapoth. Okay, something I'm not aware, I guess.
Yeah, so I think people can go to Kapoth, which is done by Sandeep Deoji. Will be shortly there.
Okay,
So,
very good. Very good.
so we'll be there, and so I keep track of my friend Nilesh. So sometimes he's not aware, but I'm tracking.
Thank you.
And so for viewers, one thing is Nilesh is there, how scientific we are, and generally it is being told to Indians is that by the Western mythological Indologists and also the Indian mythological Indologists that everything is given to Indians by the Western science, and we are just reading it because we go to Wikipedia and search on it, and we believe in it. You know, even if a lie is spoken a million times, it doesn't become truth. And so we are seeing here that it's being repeated again and again, the lies, the Greeks, as if like we do not have brains. And today also we can see Greece is a failed economy, and most of the Western economies, they are hiring Indian talent for scientific research. Then how could we be backward if our brains are producing so much now? I think
Yeah.
this is something to think about.
Yeah. And I would say, Aditya, I mean, that you're describing what is fact out there, say Greek economy. But I would say I don't want to necessarily equate the two, because I mean, the Greek also did. I mean, as I said, I'm studying Greek philosophy, or especially from a science perspective. The Thales, Anaximander, Xenophanes, very very good. Even say Aristotle, in spite of a lot of mistakes that he made, he was a decent biologist. In terms of at his time, he tried to make a good classification. So we can objectively look at any civilization, we can objectively look at any individual, we can separate the grains from the chaff, like some of the good stuff that the civilization or individual might have brought up, and the stuff that is totally false, and we have to call it out. Doesn't matter who says it. I mean, if I am doing something, like I am very particular about my own work, so I always looking for if I've done something wrong. So I read my own books, I'm looking for errors, but we have to point it out no matter where they are. And we cannot just keep this dogma just because of some regional pride, some kind of a very narrative, what you call dogma driven narrative, which is far from the truth. We cannot do that. We should not allow it. Any one of us should not allow it.
No, that's true. So thank you all for watching today, the mysteries. I think this is a great topic to discuss, and I think we really debunked some of the ancient theories. And you're right, we have to accept good from anywhere, but especially in the matters of science, the mental speculation has no value, because science is all experiential. You can see it, you can experience it, and you can actually verify, validate it. It won't change the time. It won't change with the time. So science always remains science. So thank you viewers for watching it, and for those of you who stayed so long, thank you for watching. Like me, it's almost an hour we all sat together. And do comment on YouTube and get those books of Nilesh, and from social media and anywhere else you can get access to. India, Subu Publications, and USA and other places, Amazon. It's a package deal. It's like a golden opportunity. Everyone likes packages, so this is a package deal. Namaskar, and thank you for joining.
Thank you.